linear differential equation of the type phi of d acting on y is equal to 0. This is called homogeneous, for which y is equal to yc, and yc is found using roots of phi of d equal to 0. The equation is called the auxiliary equation. This we have seen in the previous lecture. So today we will go ahead. We will find out the roots for the non-homogeneous linear differential equation. Non-homogeneous linear differential equation is of the type phi of d acting on y is equal to f of x. So f of x is not equal to 0 in this case. Such a differential equation is called non-homogeneous. For this non-homogeneous linear differential equation, the solution is of the type yc plus yp. So yc is again, using the same method that we have done earlier. Yc we have to find out using the auxiliary equation phi of d equal to 0, and yp is something new that we have to work with. Okay, so to find yp, there are three methods in our syllabus. So to find yp, there are three methods. The first one is general method. General method. Using this general method, what we can do is we can simply make some of the list of formulas, and that will turn out to be the shortcut method. And the third and the most important one is the variation of parameter. Variation of parameters. So what we will have to look at is, first of all, the general method. So the sequence is just like your derivatives. Say if this is the first principle of your derivatives, and after that general method, we can derive some of the formulas, list of formulas. I will get some list of formulas, and that I will directly use to find out yp, and which method is called the shortcut method. So it is not independent as I have drawn in the diagram, but shortcut method depends on the general method. And the third one is the variation of parameter. So in today's lecture, we will see how to find this yp. Yp is called the particular solution. Particular solution. So particular solution, finding out particular solution using the general method. So general method. General method to find yp. Okay. So this complete general method depends on one and only one formula. Okay, and the formula is, say, if phi of d acting on y, sorry, phi of d acting on y is equal to f of x is linear differential equation with constant coefficients, of course, then yp will actually be equal to 1 upon phi of d f of x. So this is the crux of this two method, general method as well as the shortcut method. So yp will be given by this. So now my uh, question is, when I say 1 upon phi of d, I need to see, as I said, that d is a derivative. D is always a derivative. Now, if you have, say, polynomial in terms of d, what I will have 1 upon d square, like we have seen in the yesterday's examples, d square minus 6d plus 5. So for an example, I have this. So now this turns out to be an operator. This is operator. It is not a number. So 1 upon d square minus 6d plus 5, this is acting on some function, say e to the power x plus sine x. So in this method, we will check or we will see how this operator operates on this function e to the power x sine x. This is what we have to see. And for that, we will use a simple logic. And the logic is, whenever I have a polynomial, I can write it down in the form, say in this example, minus 3 minus 2. Say d square, d minus 3, d minus 2. If this is plus and this is minus. Oh, sorry, this plus 5d minus 5d plus 6. Okay, d minus 3, d minus 2. E to the power x plus sine x. Okay, so I mean, trying to understand how this operator is operating on this function e to the power x plus sine x, it will be better if I just see how this operator 1 upon d minus 2 operates on e to the power x plus sine x. Okay, so what I will do is, first of all, I will operate 1 upon d minus 2. Whatever answer I get, then I will operate d minus 3 on it. Okay, so let's just revise what we have seen. So to find particular solution, what I'm doing is I'm saying yp is equal to 1 upon phi of d. So this phi of d, you're sending it on the other side. Thus 1, you're sending it on the other side. You have 1 upon phi of d f of x. So we will try to understand how this phi of d 1 upon phi of d operates on a function f of x. So I have took a particular example here, and d square minus 5d plus 6 is there, which can be factorized as d minus 3, d minus 2. So now what I see, if I am able to operate 1 upon d minus 2 on this e to the power x plus sine x, whatever answer I will get, I will operate 1 upon d minus 3 on it. So our question reduces, how does this operator d minus m operates on a function f of x? So if I'm able to get through this, we know that phi of d is a polynomial and it will always be able to factorize into this kind of forms. Okay, maybe 2 brackets, 3 brackets, 10 brackets, we don't know, depending on the degree of the polynomial. But ultimate question is, how is this 1 upon d minus m operating on the function f of x? Okay, and for that we have a concrete formula. We won't go into details how do you get that formula or anything. Just we will remember the formula and we'll use it while solving examples. So yp, or the particular integral, is equal to 1 upon d minus m f of x is equal to e to the power mx integration e to the power minus mx f of x dx. So how does the operator 1 upon d minus m operates on the function f of x is e to the power mx outside the integration, and integral e to the power minus mx f of x dx. So you find out this integral, multiply it to e to the power mx, and that is your particular solution, or yp, which is also called the particular integral. So from this you can also check that how this 1 upon d plus m operates on the function f of x. Anyone who can guess?
E raised to mx derivative of e plus m raised or e raised to mx plus mx f of x dx.
No. Anyone else?
e raised to minus mx integral e mx fx dx.
Yes. So e to the power minus mx integration e to the power mx f of x dx. Okay. So this is how this will be operating. So we just have to keep one thing in mind here, that whatever polynomial you have, phi of d, depending on its degree, I can always write it down in the form d minus m1, d minus m2, and if the polynomial is of degree n, then you will have d minus mn. So you have n roots, so phi of d can always be written in this form, and we will go on applying the, what you can say, brackets d minus m1, d minus m2 on the function f of x. Okay. So if you have written this formula, I can go ahead with some of the remarks on this. So remark number 1. So what if m is equal to 0? What will be 1 upon d times f of x? So 1 upon d means d minus 0. So using our previous rule, what we will have e to the power m into x, m is 0 in this case, integration e to the power minus 0 into x f of x dx. This was our formula. E to the power 0 is 1. So this turns out to be simply integration of f of x dx. So 1 upon d f of x is simply 1 integral of f of x. So after this, remember that 1 upon d is simply an integration. So we will see what happens if d square is there. 1 upon d square f of x. As I said that I can write this d square as 1 upon d into 1 upon d f of x we have seen just in the previous one that 1 upon d is simply integration. So 1 upon d in bracket integration of f of x dx. जो भी आंसर आएगा that will again be a function of x and 1 upon d operating on it, so that will be again an integration of integration f of x dx complete dx. So if there are 3 d's, then it will be 3 times integration. If there are 2 d's, then it will be 2 times integration. Just 1 d, then once integration. Remark number 2. Remark number 2. So if you have this kind of case, if 1 upon d minus m1 d minus m2 f of x, then what? So before going to next, I will say that this is equal to 1 upon d minus m2 to d minus m1 f of x. So no matter which one you apply first, either I am applying d minus m1 first or I am applying d minus m2 first, answer will remain the same. Okay. So remark number 3. 1 upon d minus m1 into d minus m2 f of x, that will be equal to 1 upon d minus m1 in bracket 1 upon d minus m2 f of x. So we will apply the same formula twice. 1 upon d minus m1 in bracket with the formula 1 upon d minus m2 f of x e to the power m2x integral e to the power minus m2x f of x dx. Now when I will apply 1 upon d minus m1, so if bracket I will call it say capital Q. So I will solve this integration and final answer I will get and I'm calling it Q. Then on that I will apply d minus m1, 1 upon d minus m1. So the answer here will be e to the power m1x integral e to the power minus m1x into q times dx. So remark number 3 says that you apply first one, whatever answer you will get, then you apply the second one. So fourth one, which will use some of the basic that you have studied while solving integrations. Anyone? Anyone? What can we do here?
One upon bracket D minus M1 minus 1 upon bracket D minus M2.
Why? What is it? How can you write it 1 upon d minus m1, d minus m2? No one. I should call some of the names. Advait, Devendra,
Yes, sir.
can you say something on this? Dhruv,
No, sir.
no? You have heard of any technique while solving integrations that you can separate 1 upon x minus a, x minus b?
Yeah.
What is that method? Fine, think over it. Who is next? Next is Janvi. So she must be
No,
up.
sir. No,
Huh?
sir.
No. Okay. Kishore, Raj Bora,
No, sir, I'm not having any idea.
no idea. Yash, Yash Shah,
No idea, sir.
no idea.
I
Okay, fine.
I think that
Huh? What do you think?
uh,
Look, there is a method
sir,
that you have studied while solving integration, and the method says that when you have this kind of thing, 1 upon d minus m1, d minus m2, the method says that I can separate it in this form. So what I have done, I have written in the form 1 upon d minus m1 minus 1 upon d minus m2. Okay, and to adjust this, while solving example, we will see how do we get to this. And this method, while solving integration, was called partial fractions. Partial fractions. Okay, so either you can do two integrations like in the remark number 3, or we can separate this 1 upon d minus m1 and d minus m2 using partial fraction. I will just explain, as many of you don't know how to do the partial fraction. This is just the explanation, nothing remark in it. So say if you have 1 upon x minus 2, x minus 3. Okay. So what do we do is, I want to write this as a upon x minus 2 plus b upon x minus 3. This is how I have to write down. So I can do the cross multiplication on the left hand side and equate it with right hand side. So what I will have 1 upon x minus 2, x minus 3, which will be equal to, cross multiplication will give me a into x minus 3 plus b into x minus 2, and in the denominator x minus 2, x minus 3. So this denominator will get cancelled out. And what do we have is 1 is equal to a into x minus 3 plus b into x minus 2. So in this expression, what I will do is I'll put x equal to 3, say. Put x is equal to 3. Then the first term will be 0, 3 minus 3, 0. 3 minus 2 is 1. That gives me b equal to 1. Then what I will put? X is equal to 2. Why I am putting this 3? Because I want to make one of the unknown 0. What is our unknown in this case is a and b. So if you are getting a and b, values of a and b, you can do this expression. I mean, you can work with this expression if you find out the value of a and b. So what we do is, we put the value of x in such a way that 1 becomes 0 and second I will be getting it. So now when I put x equal to 2, b will become, b will disappear from your equation. 2 minus 3 is minus 1. Then a will be equal to minus 1. So what I have got here, 1 upon x minus 2, x minus 3 is equal to minus 1 upon x minus 2 plus 1 upon x minus 3. So now I don't have to do integration twice. Okay, that's what the idea behind this remark number 4 is. I hope the partial fraction is clear. There are more rules in partial fraction. I have explained it in very short. The PDF I have forwarded you, that will help you in this. There must be some section for partial fractions too. Fine. Now once we are clear with this, I will go to the examples. Example number 1. Solve d2y by dx square plus 3 times dy by dx plus 2y is equal to e to the power x. So what do we have here? Solution. First you have to identify whether it is homogeneous, non-homogeneous. So I can clearly see that it is a non-homogeneous differential equation. So I will have to find yc as well as yp. So this differential equation can be written as d square plus 3d plus 2 bracket complete y is equal to e to the power x. So first of all, we will find yc. So to find yc, take the auxiliary equation. Auxiliary equation is d square plus 3d plus 2 is equal to 0, which means that d is equal to plus 1 and plus 2 will be there. So minus 1 comma minus 2. So roots are real, both of them, and both are distinct. So yc is equal to e to the power minus x, c1 e to the power minus x, plus c2 e to the power minus 2x. Look, if the pandemic goes on, then you will have to appear for your end term using online mode. Okay, and if it turns out that if some of you don't clear and later you are appearing for subjective, in whichever case is there, till this stage you will get 2 marks. Okay, in any of the non-homogeneous differential equation. Okay, so as you can see, there is nothing much to do in this. There is no integration, there is no derivative. The roots also you are finding out using your calci. So you must know how to get up to this. Now I will go ahead. Now yp will be equal to 1 upon d square plus 3d plus 2 e to the power x. So 1 upon d square plus 3d plus 2 I can factorize as, you can split the middle term in such a way that the product is plus 2 and addition is 3. So sorry, product is 2 and addition is 3. 2 and 1. So what we do is d plus 2 d plus 1 e to the power x. Now once we have this, we have seen in the remarks that there are two methods. Either I can apply one by one, or I can use the partial fraction here. So I will apply one by one, d plus 2 outside the bracket, inside 1 upon d plus 1 e to the power x. So with our formula, a d plus m formula, if you have written it, check it. So what we will have, e to the power minus x outside, integral e to the power x, e to the power x dx. Now I will put e to the power x as t. So if you put e to the power x as t, e to the power x dx will become dt. So later I will write it down in the upper corner. So what we have, 1 upon d plus 2 in bracket e to the power minus x. You put e to the power x as t, e to the power x dx dt, integration of e to the power t is e to the power t. So this will be the answer for this. Now apply d plus 2, so that will be e to the power minus 2x, integration e to the power 2x, and the bracketed term e to the power minus x, e to the power x dx. So e to the power minus 2x, integration e to the power x, e to the power x dx. Again do the substitution, put this term as t, and this e to the power x dx will become dt. Integration of e to the power t is e to the power t. So the final answer will be e to the power minus 2x, e to the power x. This is your yp. Take 2 minutes, read it carefully, understand it properly, and then we'll go ahead. Okay. So what we have got, yc is equal to c1 e to the power minus x plus c2 e to the power minus 2x, and yp in the last step we have got e to the power minus 2x e to the power x. So the solution of given linear differential equation is y is equal to c1 e to the power minus x plus c2 e to the power minus 2x plus e to the power minus 2x e to the power x. So I have added yc and yp. That is the final solution. Next example. Example. Solve d2y by dx square plus dy by dx is equal to 1 upon 1 plus e to the power x. So auxiliary equation, what do we have? Auxiliary equation d square plus d y is equal to 1 upon 1 plus e to the power x. Okay. Oh, sorry, I'm really sorry. Not the auxiliary equation. This is just the transformed equation of the above. So the auxiliary equation from this will be given by d square plus d is equal to 0. So that will be d into d plus 1. I have took d common is equal to 0, which means that d is equal to 0 or d is equal to minus 1. So we have got two roots, real and distinct. So yc is equal to c1 e to the power 0 into x plus c2 e to the power minus 1 into x. So which is c1 plus c2 e to the power minus x. This is your yc. Now let's go for yp. Now yp is equal to 1 upon phi of d. What is our phi of d here? D into d plus 1. And our f of x is 1 upon 1 plus e to the power x. So what I can do is I can apply d plus 1 first, then I will apply d one way or the other way around. Let's use partial fraction since we have both the methods. So we'll practice both of them. So 1 upon d plus 1. How we need to write down? This is not supposed to be right in your paper. This is the rough work that you have to do separately and find the values of a and b. Plus b upon d plus 1. I'll make a separate section here for this. So after this, what we will get? 1 is equal to a into d plus 1 plus b into d. So put the values of d in such a way that I'll get the unknown. So if I put d is equal to 0, put d is equal to 0. Then a is equal to 1. Then I will put d is equal to minus 1. Then b is equal to minus 1. So what we have got, we will use it over here. So yp is equal to 1 upon d minus 1 upon d plus 1, 1 upon 1 plus e to the power x. Let's open the bracket. 1 upon d, 1 upon 1 plus e to the power x minus 1 upon d plus 1, 1 upon 1 plus e to the power x. So the first bracket, Tanishq, and this Tanishq doing is not there. Is Shaunak there?
Yes, sir. One
Huh?
upon d, 1 upon d in bracket e raised to x.
No. What is 1 upon d? 1 upon d is nothing but
Okay.
1 upon d is, anyone else who can tell me what is 1 upon d? Okay, let's find someone else. Shrutika, absent.
No, sir.
Huh, you cannot tell me what is 1 upon d. Omkar, Omkar, not there. Kishore, Shantanu,
No, sir, I don't have any idea.
no, don't have any idea. Dhruv, can you tell me? Where is Dhruv? Dhruv have left. Dharmik, Shah,
No, sir.
no. Check out your remarks. You have seen the remarks. We have written a lot of remarks. What is 1 upon d? The first remark.
Sir, f of x dx.
What is the first remark? What does it say? 1 upon d f of x.
Sir, integration f of x dx.
Very good. So 1 upon d is nothing but integration. So 1 upon d in bracket 1 upon 1 plus e to the power x will become 1 upon 1 plus e to the power x dx minus 1 upon d plus 1. We will use the rule e to the power minus x integration e to the power x into 1 upon 1 plus e to the power x dx. Now integrating this is a bit difficult task. Not actually difficult, but you just have to adjust the denominator and numerator. So what I will do is I will add and subtract e to the power x. in the numerator, or I can multiply and divide by e to the power x. Both the ways it should work. E to the power x in bracket 1 plus e to the power x dx minus in bracket e to the power minus x integration of e to the power x upon 1 plus e to the power x dx. Clear up to this? Now what I will do is I will call this first integration as I1 and second integration as I2. Note that our answer will be yp is I1 minus I2. So on the next sheet I will find out I1 and I2. What is our I1? I1 is equal to integral e to the power x upon e to the power x 1 plus e to the power x in dx. Okay, let's just do it in one step. Yp is equal to this minus integral e to the power x upon 1 plus e to the power x dx. So what I will do is I will put 1 plus e to the power x as t. So if you take the derivative of this, it will be e to the power x dx is equal to dt. So it turns out to be the first one e to the power x dx dt. E to the power x will be t minus 1 into t minus integral dt by t. In the first one, use the partial fraction once again, and the partial fraction will be 1 upon t minus 1 upon t dt minus integration of 1 upon t is log t. There was one more term outside this that was e to the power minus x. I forgot to write it down. So clear up to this. Then you take the two integration 1 upon t minus 1 is again log t minus 1 minus integration of 1 upon t log t minus e to the power minus x log t. Resubstitute the value of t, I mean simply t, the log of t minus 1 is e to the power x minus log of 1 plus e to the power x minus e to the power minus x log of 1 plus e to the power x. So we'll simplify this. Yp is equal to x minus log of 1 plus e to the power x minus e to the power minus x log of 1 plus e to the power x. The general solution is y is equal to yc plus yp. You can put the values and that will be the final solution.
सर ये क्वेश्चन कितने मार्क्स का रहता है?
5. In theory paper, If those are MCQs, then it will be either find out YP or you find out YC. Fine. So general method ends here. There is not much to ask about the general method. The next lecture will be very important, in which we'll talk about shortcut methods. So in shortcut methods, again, we will have some list of formulas like you had in derivatives, and you go on finding out the particular solutions without any integration. So for today, we will stop here. Before leaving, let me just download the attendance. If you have any issues, please let me know.